Hello everyone, my name is Michael Downey, Library and Information Services Officer at the AWRI, and it's my pleasure to welcome you to today's webinar, the second for the 2015-16 program. Now the topic for today is monitoring Brett, what are your options? And our presenter is Dr. Tina Tran, research scientist at the AWRI with a focus on applied research. Amongst other achievements, Tina has been involved with developing novel wine yeast strains, an audit methodology for resolving microbial contamination issues during wine packaging, and also providing solutions for monitoring Brett in the winery. Tina is also a finalist for this year's SA Science Excellent Awards. Now, before I hand over to Tina to tell us more about the topic for today, a couple of notes on what you as the audience can expect. The format for AWRI webinars is a short presentation followed by a Q&A. The session is being recorded and will be available to view via the AWRI website. And finally, for those that are new to webinars, it's important to remember that webinars are interactive. So to ask a question during the Q&A, please type into the questions section of your control panel in the bottom right corner of your screen. And for those with access to a microphone, there is also the option of speaking directly with our presenter by clicking the raise hand button, which is located in the top left section of your control panel. If you would prefer to ask a question via email, please do so at infoservices@awri.com.au. We are monitoring this inbox and we'll get as many questions through to Tina as possible. Okay, that's enough from me. I'm now going to hand over to Tina to present her topic.
Thank you, Michael. So today, as Michael said, we're going to talk about some methods which you can use to detect Brettanomyces in your wine or in your vineyards. So I've got a picture up there which is just our crime scene photo, and no, we do not use a magnifying glass to detect Brett, but putting all jokes aside, Brett is an important issue in the wine industry. In a month, it can turn your wine from lovely floral, fruity flavours to, as we know, sort of wet dog and very undesirable aromas and flavours. So I guess it's quite a difficult issue to remedy. You'll have only very few options really. Sterile filtration to try and remove what cells you have in there. Reverse osmosis, which can strip the wine and remove flavour compounds, or you can try and blend it away. So I guess the best case is to avoid Brett in the first place and try and control and to do this we need a good detection or monitoring system. So today I'll just talk about some of the common methods, and it is a very general overview, and we all know of the traditional plating or microscopic methods. Then now it's sort of moving into more molecular based with PCRs and sequencing. And there are also commercial kits available as well. So I will talk about the pros and cons, and again this is only a generalised view. So we'll look into turnaround times, cost per samples, capital costs that you might need to set it up in your lab, sensitivity and other things like that. So I'll start off with plating. With plating you take typically 100 mils, put it through a 0.45 micron filter, plate it onto WL, which also contains cyclohexamide. And cyclohexamide is to try and prevent other yeast strains from growing and select for Brettanomyces. You can take this one step further and do a wet mount and look for, I guess, distinct Brett morphologies. But there are limitations to this method, and that is you can have other yeast species which are also cyclohexamide resistant, and VBNCs, which stands for viable but non-culturable. So the standard testing is to wait for 10 days and then you'll monitor whether there's growth or not. But in some cases, the Brett might take longer than that, so you might miss it. And also with microscopic perusal, sort of need to be a bit of an expert to identify those distinct morphologies. And it also adds to the subjectivity of it as well. So this slide is just, it's a bit outdated, but all I wanted to really highlight was that Brett is still an issue, and there has been a rise recently. And this is just, the red bars just show the number of negative results. So in 2013 we had 200 negative results, but there were still about 100 or 80 positive Brett plates. So another common method used is just chemical analysis, so looking for the taint compounds that are produced by Brett. And I guess by this stage you already have an issue if you can detect 4-PEG. In this graph, I just wanted to again highlight that Brett is still prevalent. We had quite a rise in total sample numbers, so that's the green triangle there. It was over 1,000 submitted for 4-PEG analysis. And in terms of the detection or above threshold levels, it is wine matrix dependent, but I guess that for the purpose of this slide, I've just put it around the 300 mark, and we have about 30% of samples above that detection threshold. So some of the limitations I just want to highlight here is that even though in this method you may not be able to detect any 4-AP or EG, but it doesn't mean that you don't have Brett in the wine. And also it requires the use of GCMSs or really expensive equipment and a specialised technician to run the sample, so most of the time you have to outsource it, and by the time you actually detect something you already have an established population. And of course sensory, so a lot of people might rely on just their own palate or the aroma and try and detect bready characteristics there. If it is in a controlled and environment and you have consistent panelists, then sensory is an option and can be reliable. However, if it's just in the everyday winery, the main limitation, it's dependent on the wine matrix of whether you can detect it or not. It's very subjective, and people can develop selenosis where I guess they become almost resistant to the taint. And now these days with the molecular methods developing, PCR has become quite I guess a prevalent method used, and PCR stands for polymerase chain reaction, and what you're doing is amplifying up a targeted section of the DNA, and that particular section of the DNA distinguishes Brett from other microorganisms. So what happens is you take a sample, we extract the DNA from that sample, from the cells, and run it through the PCR. And in PCR, you start off with, I won't go into too much detail, but pretty much you goes through different temperature cycles and uses Taq polymerase to amplify up the DNA. From there, you can do several things, and that is, so I've just got a picture of a gel there where you can actually visualize the DNA, but you can send that off for sequencing and compare it to the database and determine whether it is bred or not definitively. You can also do RFLP, which stands for restriction fragment length polymorphisms, and that's when we use restriction enzymes to cut up the DNA, and it's sort of, Brett has a distinct pattern that we can match it up against reference strains. You can also take that one step further, and there have been publications where the RFLP, I guess, signature is SO2 resistant dependent. So with all the Brett strains we have out there, there's been work done by Chris Curtin where he's been able to categorize SO2 resistant strains and not so resistant strains via similar method. You can also use transposon PCR, which is targeting a different area in the DNA, but again, it can also tell you whether that sample contains Brett or not. There are also antibody and ELISA assays, but probably not as common. And of course, sort of commercial kits, which I don't have all the details of how they exactly work because of the proprietary. So I guess one thing to think about is whether the DNA that you've amplified has actually come from viable cells. So using PCR, because you're looking at DNA, it may have come from a non-viable cell, which is still intact, and so it will be detected on PCR. So it's just one thing to keep in mind whether it is actually picking up viable cells or not, which you cannot tell from these results. And I would always take it one step further and do the viable plating on WLC. So I'll just talk about an example of a commercial kit available that can be set up in labs, and it's called Veriflow. It's probably one of the more newer commercial kits available. Again, it also uses PCR, and the kit contains a digestion I guess, solution as well as a PCR solution, so it's quite easy to use. Part of the kit is a cassette which you use, and I'll just show you some examples of results. So the top line is called the control line, and that is just an indication that the assay is actually working. And what we're looking at here is a result of a wine prior to spiking with Brettanomyces. Then the middle square has a result where it's been spiked with about 500 CFU per mil of Brettanomyces, and you can see that the bottom line, which is the indicator line, shows quite an apparent red line indicating that it is positive for Brett. And then on the third or final column you have, I guess the indicator line is less apparent, and that's after Brettanomyces treatment. So we can see that the treatment has worked in that it's reduced the numbers. So I guess one of the main limitations here is that it does require a minimum of 10 CFU per mil. in order for you to actually read it on the cassette. So I've just run through, I guess, more commonly used methods, and in this final summary slide, or I guess general summary, I'll just go through different methods such as the plating, RFLP PCR, RT-PCR, which is similar principle. It's called reverse transcribed PCR, and then followed by chemical analysis, sensory, ETS Scorpion, which is another commercially available way of detecting Brett, and Veriflow. So I just wanted to point out that this is a very generalized overview and is only my sort of summary of trying to compare different methods available. So I'll start off with enumeration, so whether you can determine how many cells are actually in the sample. In using plating, it is possible, but it does have to be between 30 and 300 cells per mil to actually quantify it. It is possible via PCR methods, and in terms of chemical, it's not really that easy to sort of trace it back, nor sensory. The commercial kits can give you approximations, not exact numbers as you could do with WLC, but it can still give you a rough estimation of the level of contamination. So next we'll talk about the background. So as I mentioned earlier, with WLC you can have yeast strains that are cyclohexamide resistant as well. And so I've sort of just marked that as a medium in that it is possible to get some background. With PCRs and chemical analysis, it's quite distinct and specific to Brett. So in terms of picking up any false positives or background, then very unlikely. The same with the commercial kits. Sensory, I guess you can have some taints that people may interpret as a wine being Bretty, so I've just marked that as medium. Next we have sensitivity. So I rated PCRs as well as WLC as highly sensitive in that they can, for example, with WLC you can pick up one cell in 100 mils of sample. So that's why I've rated that as highly sensitive as well. Whereas the commercial kits, they are PCR based, but then you have the secondary step which reduces the sensitivity a little. So next we're looking at the cost per sample. So these are just approximate amounts. PCR and plating are very cheap methods. If you want to look at flow PEG, it's a bit more expensive. Sensory, of course, that you can do it yourself, but it is, I guess, in actual consumables cost, it's very low. ETS Scorpion is in the high range, and Veriflow is sort of in the medium range in between chemical and just normal plating analysis. So the chances of false positives, I've highlighted this mainly again with the plating in that it's not definitive. It's sort of you're just looking at a colony on a plate, and whether that is just another cyclohexamide resistant yeast or not, you can't really tell from that assay. And again, the same with sensory. The remainder of the assays are quite accurate. If you get a positive for those, then you're pretty certain that you have Brett there. This next is turnaround times. WLC plating, you always have to wait up to 10 days, and that's mainly because cyclohexamide is a toxic compound, and it slows the growth of Brett, which is already a slow-growing microorganism anyway, so it can take quite a while to actually get results. PCRs, chemical analysis, sensory, yeah, all of those are pretty quick. So yeah, depending on how you actually do the analysis for sensory, I've put 3 days there if you're going through our quality panel. So they're all pretty quick methods. The capital cost. So if you wanted to set up these assays in-house, plating is fairly low. You need very basic micro equipment to set that up. Whereas PCRs, you need to set up or buy, I guess, a PCR machine, which is around the 5,000 mark. RT-PCR is a bit more sophisticated and can be more than a $5,000 setup. And certainly with for a PEG analysis, those machines are pretty expensive, so that is why they're mostly outsourced to commercial labs. And Veriflow is sort of in the medium range, similar to a standard PCR. Whether it's user-friendly or not, well, plating is fairly easy. Same with Veriflow and, of course, sensory. Practically, it's not a difficult thing to do. In terms of PCR, just mark that as a medium because you do sort of need some sort of training there and know how to use a micropipette, etc. And chemical analysis, you definitely need specialised personnel to run those machines. In terms of reproducibility, well, with plating, you're only running 100 mils, so you have to make sure that, I guess, the sample is homogenized, and when you're sort of putting it through this 0.45 filter and say you've taken a sample at the bottom of the barrel, which is where Brett would most likely lie, it can be quite difficult to filter through as well. So given the background that you can get on plating, when you plate out two samples from the same barrel, they may or may not come up the same. So that's why that's been marked as a medium. And the same with sensory. It's, you might have a cold that day and can't really smell the bread in the wine. So that can be a bit not very reproducible unless you have a quality panel. In regards to PCRs and chemical analysis and the commercial available kits and services, they definitely have quite high reproducibility and quite consistent results. In terms of viable but non-culturable cell detection, that's a bit of a grey area in that, yeah, we haven't really been able to sort of, or there's not solid evidence that we can detect them by any of these methods. Certainly with plating, if it's VBNC, then you're not going to pick it up. With PCRs, there is a chance that you are picking up cells that cannot be cultured, but determining whether the result that you've obtained has come from a VBNC, you can't tell from PCRs. And that's why I've also listed the commercial available services and kits as a maybe as well, that they could possibly detect VBNCs. And of course, objectivity, of course, with sensory, it's a very, I guess, somewhat subjective unless you're in a controlled environment. And I've put plating down as being sort of in between because of the background that you can get. So if a technician is looking at a plate and doesn't take that extra step of doing the perusal, or they're not trained in actually identifying the morphology of Brett, then they might mark that one as a positive. So that's why I've marked that as a medium in terms of objectivity. So just to summarise, this is only a very generalised overview, and it's not an absolute table. So it's just something to use to keep in mind that you can see that there aren't any columns that are all green, and that's because there is no perfect solution, and I guess the main thing is to just be aware of the limitations of the methods. And I would recommend to use a combination of methods if you really want to make sure that you do have an issue. And most likely there will be more molecular methods being developed in the future, and that's because I guess they're reliable, reproducible, and you're certain that what you're picking up is actually Brettanomyces. So I guess with all this, with all these methods, at the end of the day, we want to detect Brett because we're trying to prevent this from happening. So thank you for listening and watching, and I'll take questions if there are any.
Thanks for that, Tina. Yeah, we'll go straight through to a Q&A from here, as Tina's mentioned. Just a quick reminder to the attendees to ask a question, please type into the question section of your control panel. Alternatively, click the raise hand button if you happen to have a microphone and would wish to speak directly with Tina.
Oh, okay. So we have a question here from Akash, and the question is there a specified time when we send the wine for sampling? I guess certainly after primary fermentation. Usually Brett develops at the end of primary, and normally you'll start smelling it if you go through MLF. But anytime, I guess, when you suspect sensorially that you have an issue, but as a routine, we always recommend monthly checks of wine, either plating or one of the commercial kits or chemical analysis. So yes, I hope that answers your question. Okay, the next question is, you haven't mentioned the sniff Brett type testing. What are your thoughts on that? And I guess I haven't mentioned all the Brett methods available. From my opinion, it's personal, but it's not something that is, to me, a very objective way of measuring whether you have Brett. I'd rather go for the more definitive methods. Okay, so the next question's from Toby Porter, and Toby asks, in regards to that table I had up, I had a few with NA and specifically for scorpion detection method, and that's because it's not something you can really set up in your lab. It's an outsourced service, so the way it works is you send in your samples to them and they will analyse it for you. Next question is in regards to sparkling wines. Well, certainly there's nothing stopping you from monitoring Bretts and sparkling wines. The main thing to keep in mind is, of course, we degas prior to performing the assay, and always picking up sort of as much solids or that is in your wine sample, so making sure it's mixed before actually sampling. Okay, the next question is, could you tell us more about the sort of organism that Brett is, its viability, nutrients required, usual habitat, and its genetic cousins? So Brett is, it's a very slow-growing microorganism, but in the right conditions it will be able to flourish, and when it flourishes, it requires precursors such as caruric present in both red and white wines in order to produce the 4-AP tank compounds. It's ubiquitous, really. It's found just about in everywhere, and in terms of genetic cousins, yeah, I'd say it's quite a distinct species or genus of its own.
Okay, thanks for that, Tina. We don't have any further questions just yet. Give people a few more seconds to send in any final comments or queries. And if we don't receive anything further, we'll start to wrap up. Okay, looks like that's going to be it for today. Just a minute, Tina. Thank you to Tina for presenting today, and thank you to everyone who's attended the session. For attendees, you'll receive a follow-up email with a link to this recording and also a link to the survey. Should you need to follow up on anything, please feel free to contact the AWRI directly. Next week's webinar is coming from Professor Robert White from the University of Melbourne, and his topic will be soil health. If you haven't registered for this webinar, please visit the AWRI website to do so. And once again, thank you for joining us today, and please do check out the AWRI's online webinar program to register for future sessions.